Well, hi everybody, Tim again. And today we have a TS940, but you've never seen this before. So, I know you're probably thinking, haven't I torn this apart enough? I should have probably put a zipper on it, but one of the things I'm curious about on this is the output, the power output on sideband. So on CW, and we're hooked into a dummy load through a watt meter, but we'll use the watt meter on here for now. Stick it on CW and key it up. Maybe turn it on power so it's reading power there and key it up. A little bit over 100 watts right there. And the bird's showing about the same thing. Okay, good with that. Now on sideband, we'll go upper sideband again. It's been where it's always at, usually in the 28 range somewhere. So 28,444. Put an upper sideband, and so we get hello, hello. If I really whistle into it, I can get up to 100. And as you look, that mic gain's all the way. So just a normal mic gain, and speaking like a human. I don't have the processor on or anything. Hello, hello, hello. Almost nothing. So now I'm going to switch over. We'll take a look at the bird, and I'll show you pretty much the same thing. This is the one I put the peak reading kit in, so we'll turn it to peak. Okay, so I'll start with it at the halfway point, and you'll be able to see it on the bird. We'll zoom in a little bit there. And it's going to show you the same thing. I mean, this is like a futile test, but hello, hello, hello. See, we're getting, what, 10 watts? Now that's halfway. When I turn it all the way and kill it all the way over. Hello, hello, hello. I'm getting close to 80 if I whistle into it, and that's with the gain turned all the way up. So, I was just showing you that it kind of jives with what that needle's showing you. So I can back out of here again, so you can see more of what I'm looking at. Okay. So, if I put the processor in, and I have adjusted this previously. Hello, hello. It's easier to get it all the way up there, but then again, like I said, if I just talk normal, 1 2 3 4 1 2 3 4, the power's still 70 80 watts, about the peak that I'm getting. To me, that doesn't seem correct. I'll turn that down. I'm going to turn the mic gain all the way down and just see what happens. 1 2 3 4. See, it doesn't really affect when you're using a processor because it uses the in or the out, the in and the out. The processor in and out. But when I pop that back out, not using a processor, and I talk at about halfway, I have to yell with my mouth in the microphone practically. So I want to take a look at that. So looking at the 3D BB, the three-dimensional blackboard, for those of you that remember Tennessee's Tuxedo, I want to set all the settings on the radio to look like the specs are telling me, and then we're going to feed a signal into it and just kind of see how things look on the output. And I'm sure we're going to end up taking the covers off, but let me get this all configured like that, and I'll be right back with you. Oh, by the way, this is the version 3 alignment manual. So if you're working on one of these or any radio, make sure you have the settings all according to the alignment manual before you go and start to test things. Some of these things will matter, some won't. The problem is usually when they tell you to put things a certain way, they don't tell you to unput them a certain way to do different tests. So a lot of times in the manual you can get kind of messed up with that. But we'll start with this and just see where we end up. Okay, so next we want to look at is the level diagram. I'm going to try and get this squared up a little bit better for you to look at, but let me rotate it. And this pretty much tells us with a signal in. Let's zoom in a little bit here. With a signal in, what we should expect along the road. And at the where to go at the very end here, down at the bottom, it should tell us some additional stuff. So let's see. Frequency 14.2, mic input 20 millivolt, 1.5 kilohertz. So that'd be millivolt RMS. Now it doesn't tell me if that should be on sideband, AM, FM. I'm going to assume sideband, because when I look out here, it's telling me basically this is the output here, 70 volts, so that's about 100 watts. And I don't believe it puts that out on FM or AM, so we'll go, whoop, not too far. We're going to go and just pump a 1.5 kilohertz signal with 20 millivolt RMS in and see what our output is along the way a couple of times before we even crack it open. So let me get that set up and we'll be right back. Okay, let's get this guy set up for 1.5 kilohertz. 1.5 kilohertz, and the amplitude we're going to set it for 20 millivolts RMS. Alright, the output's not turned on yet, so we'll go over here to the radio. That's my chair making all that weird rolling sound. Alright, and we're just going to check a couple of things. So as you can see, I have the voltage coming in, and I made this connector up a long time ago for testing this. And here's the from the signal generator. So we'll put it on upper sideband, key it. Shouldn't have anything. So I'm going to turn the signal generator on with the 20 millivolts and see where we end up. Now, as was indicated, all these buttons are pushed in. Okay, so there's the 20 millivolts, and the signal's coming in, going to sideband. I got nothing coming out. As you can see, we're on power. I'm going to turn the processor off for a second. Oh, I got to turn the mic. I'll turn the mic gain up when I do that. So it is working. The processor settings are both at 0, as the book had told me. And again, I don't know if any of that has to change from the initial setup for alignment to this page. So I'm just taking it as a grain of salt. If you look at it though, at the I'll go back and show you the drawing in a few minutes. It tells me what the voltage should be along the way, even before we get to the processor. So at least I can check out a couple of circuits just to see if something overdrove an amp or a cold solder joint that these radios are known for. We'll take a look, but let's just, what I want to do is I want to knock this back so the processor's not in, turn the mic gain to about halfway, and as I showed you before, they were showing the 70 volts at the output. Leads me to believe that the setting here should cause 100 watts out at some point, even if it means adjusting the processor, which they do later on. Told me to turn off the processor to get it. So actually we'll try that. I'll put that back down. Let's just see if the processor is going to let us even get anywhere nearer. Maybe I'll key it up first. There we go. Well, if I bang up both of the processors, I do get that signal out. So I'll put this one about halfway. I'll put the processor in about halfway, and I'm able to get it. And the AG or the ALC seems to be working fine because it's right after about 100. You can see it won't crank up any higher than that. It kind of bangs it right there. So that's right about what we want. I don't know I normally don't use a processor, so I don't know what the typical settings are for that. But I do know that to have to crank this all the way up, and again, that's cranked all the way. So without the processor and 20 millivolts, I'm only going to get 15 watts out. So what I'll do is I'm going to actually turn the signal generator up from 20, we'll go to 40 millivolts. Oops. So there's 30 and there's 40. And let's turn this back down and see what happens. Alright, at 40 millivolts, I'm getting to about 75, maybe 80. Signal seems to be wavering a little for some reason. I don't know why. Even at, let's go to 50 millivolts and see what we get. 50 millivolts is right about 100 out, and that's cranked. So I think the next step we have to do is open it up, and I'll show you why. Okay, and I do realize it's a little bit crooked. Sorry about that, but that has to do with me breaking everything last week. But anyhow, as you can see, the 20 millivolts going in. That's the first thing you see, right? I'm gonna put my finger and try and do this. Is this going to work? No. Just curious. There's the 20 millivolts going in right there. So after that first amplifier, and all that's on the, I believe that's all on the IF board. I'll look, let's see. It'll tell me over here if I look actually. Yeah, it's the IF board. So the nice thing about this is it cuts all the other crap out. This is where we want to follow the audio signal through here. This, even though it's not labeled, I'm imagining that's the mic control button. You know, the mic audio gain. But the first thing that I'll want to do is this guy right here, and I'll check to make sure that I have a little bit over a half a volt out with 20 millivolts in. And I think that's very possible that would be a good suspect. If somebody overdrove this radio, when I got it, it had some modifications done to it. I don't know how much that transistor can take, but anyhow, it's possible, and then that would be really nice and easy, so that's probably not it. Then we'll go down the road and follow it through. There's the this is the balanced modulator right here for sideband. And then this will be your filter for either the upper or lower sideband. Would take out the carrier and just pass through either the upper or lower, whichever one you choose. Oh, and then here's a crystal filter. That's probably, I'm imagining 3 kilohertz. I don't know. I'm just figuring it's the sideband. I don't know where that's actually at. Then it goes through, and then here's where it breaks down. For the processor stuff goes this way, and the non-processor, just regular modulation, goes this way, then through another filter, and yet another filter. These are the usually the crystal filters, or the aftermarket filters you can buy. At least this has a couple of them in it. And then we go through all that. But as you can see along the way, they start to tell you what kind of voltages you want to see. And then there's, like here, there's a note. But I'm hoping we don't have to get that far. I'm really hoping it's the first transistor. But this hasn't been a lucky month for me. So anyhow, I'll take the case off, and we'll get in there and start probing around and see what I can blow up. Okay, so Q36, get the bottom panel off of the 940. Q36 is, let me see if I can point to it. Where's my trusty pointer? Q36 is right about up in here, right between these two capacitors. See if I can zoom into it to give you a better look. Looks like it's got a heck of a shadow on it, but so it's going to be, and I'm going to take the voltage reading, so I'll get in here and you'll see where I'm probing. Right there is 1.2 volts, and according to the schematic, about 1.3 would be the emitter. The base should be about 1.8. The base is 1.83 volts. And then the collector should be around 4 something, I believe. .5, and the collector says it should be 4.2, so that's all close enough. So we at least know that it's got power to that first transistor. Let's see, so the next thing I want to do is I'm going to go on the collector and see what happens, what the signal output looks like when we put the 20 millivolts into it. So let me get everything hooked up again and we'll be right back. Okay, so we're ready to stick the scope on it, and I'll turn you around so you can see the scope. Yep, it's moving. And I have the 20 millivolt signal going in. I don't think I have to key it for this. I don't think it makes any difference, transmit or receive. That's still going in. Then we'll take a look at that. Okay, so you're watching the scope. I have it set at, oh, what's it set at? I think 1 volt per division, and I think make it a little less than that. We'll go 0.5 volt per division, and the reason I'm going to do that is I'll show you in a minute. So first I'm going to look at the signal going into, this should be on the base of Q36. This will need it a little bit smaller so you can see it. Let me. Okay, you can see there's the signal on the base. Now we'll look at the signal on the collector. Get in here and see where I'm looking. Alright, as you can see, it's definitely getting amplified. It's saying 150 millivolts right there. So let's consult the schematic or the flow chart and see what that tells us, because even though it is definitely amplified, it seems like it's lower than what they're saying. And I'm just going to move the potentiometer for the microphone gain back and forth. That's all the way at 0, that's at 10. You'll see it means absolutely nothing. It's in receive. I'm going to put it in transmit and do the same thing. Start at 0, it's in transmit with no output. I'm going to key it up. Goes up to about 10 watts, nothing. Okay, I just wanted to confirm that when I moved the modulation, the microphone input potentiometer, that nothing was actually happening. Okay, so I'm going to pull this off and get this out of my way here. So what I want to do is I just want to double check, because I don't know what I'm seeing here. But I'll zoom you up to the schematic. Ooh. Okay, hopefully it'll, yeah, it looks like it's going to focus. There we go. So at the schematic, we're right here. I was testing here. Here's the base, the input. So the signal comes in through here. So I just want to double check and make sure that these resistors are okay, that I'm not dropping excessive, and I doubt that the cap would cause the issue I'm seeing. I mean, if it was shorted, it would be passing more, and if it was open, it would be passing nothing. So, but I'll check all those components. But I just want to double check here, so let's see what I can get at, and then we'll show you the other screen. Not that one. Not that one, dummy. This one here. So see, it showed me with 20 millivolts in, which we have, that I should have about a half a volt out, which we do not have. I'm going to blame that on the amplifier or something else. Okay, here we are back at the Riddler's Cave. And for any of you that remember the old original Batman series, that we showed it at an angle for some reason. But so what I want to do is want to follow the signal, and basically I took the liberty of circling things, so we'll have to keep looking. This comes from the mic switch, goes straight in, and it comes to our Q, well, through a couple components, and to our Q36. Then it comes back out of Q36, and it goes to pin 3. I'm sorry, connector 3, pin 1, that's going to be on the IF board. And if you look up top, this even calls it, somewhere up here it says the IF board. There it is, IF unit. So that's the nice thing about these. You can, even though it's a PDF file, you can click on them and save them in Paint, and then write all over them to make life easier on yourself. Then when you're done, don't save it unless you want to save it. But so what I did is kind of do this. So we're going to look at the signal coming out, and it should look pretty much the same as it does on the collector here of Q36. So here's another thing to throw at you too. If you look in the manual, get used to these. Here's the board layout for the IF board. So this is how you can find things on these really crowded boards. Of course, you can see my red circle. There we go. That would be up here is the connector we're looking for. There's Q36 that I have circled, but we'll zoom in. So since we already know where Q36 is, we don't have to look too much. Right across from it, and then MV1 is pin 1. That's the first thing we want to get to. So it'll be the highest one, basically the pin closest to Q36. So we'll look at our signal. What I'm going to do is I've got them all traced out there, so I'll zoom in on the scope and I'll show you between the scope and the schematic where, rather than just watch me poke around on the board, because you won't see a lot. But I'm hoping to see the same signal at the collector of Q36 as I see right there, and then we're going to follow it to where it goes after that. So okay, so now on to the collector, and there we go. We're seeing, looks like about 150 millivolts. So now I'll go to pin 1 of that connector. Pretty much the same thing. So that's okay. We know that we're good there. So now, where's the next place I want to go? Okay, so there's the collector right here, where we just tested, and we came down and we tested this guy right here. So we want to go to switch E, SWE. It's going to be number 39, and we're going to look for a pin that's called MV1. So let's go to, like that, we'll come over here, switch E right here, and here's 39, and MV1 I already got circled in red. Comes in, and where's my pointer, since a lot of times that cursor doesn't work too well, but comes in. This goes down to the FM over there. We're not worried about that right now. Goes up to here to a potentiometer. That's the mic potentiometer right there. Hopefully it's catching all this. Yep. And then it comes back out. As you can see, there's way too many connectors on these 940s. Let's see. Comes in that way, comes back out, and it's going to go to switch A, pin or connector 20, called MG, probably for something like mic gain. So let's see if we red line, switch A. I didn't draw a red line yet, but switch A is over here, I believe. Yep, switch A. And I think that says 20. And then there's MG, the bottom one. Comes in, goes through the processor switch, then back out through MV2, which, and now it's renamed as MV2. And it's going back to the IF board, pin number 19. So let's see. We go back to the IF board. So we'll look at the picture real quick. Where's the IF board here? I think it's somewhere in the middle of the board. Let's zoom out a little bit. I circled this, so that must be, yeah, that's 19 there. So now we know where it's at on here, so I'm gonna just find it on the board. Here's the fillers, here's the switchboard that sits on the very top of the IF board, so it's right down below it. Looks pretty easy, actually. There's a lot of connectors on this board. So let's see. Let's go, we'll check it coming out of the, we're coming back into the board at that 19 and see what we get. I'm sorry, yeah, is that 19? Yeah, 19, and it's going to be, let me zoom in so we can see what we're going to, oh, that's great. I lost it. There it is. MVG, did I say? Or MV2? Yeah, G would be ground. I don't know what the 2 stands for. So it's going to be the bottommost pin, and I can tell there's a 4-pin, and then we decide to be a 2-pin. And if I remember correctly, right here, this little guy here, that's the balance modulator that can knock it off balance basically to allow sideband. So it's going to be right, and I know that looks like a wee little tiny circle on this board, so it'll be right above it. So let's see if I can find that. Okay. I'm going to zoom and show you where it's at on this board. Okay, so there's 2 connectors right here, and as you can see, it's this guy right here. And the reason I'm painstakingly showing you where this is, I'm going to zoom in for a second, see if you can see. So I have to readjust here. Come on, camera, there we go, you can do this. Back out again a little bit. A little more, I guess. I had one of those weeks last week where I broke everything I touched, and unfortunately I kicked the camera over, so now it seems to be very moody. Had to super glue it. Anyhow, as you look here, there's a 3-pin and then there's the 4-pin. The 4-pin is white wire down here at the bottom. Just when I was trying to find a connector, I moved that wire, and when I moved it, I kind of felt it click. So I have a feeling that our issue's gone all of a sudden. But that's kind of the deal with these 940s. It's either going to, usually one of these connectors is goofy. So what I'll do is I'll take it and recrimp the pins, but I want to double check now. It's usually either the one of the connectors is goofy or solder joints. In which case, if I can get it to happen again, I will gladly take the board out and go over that. But I went over one of the other boards in here, and it's definitely a labor of love. So anyhow, let me get the meter fired up, but we're going to look at the watt meter and I'll see what I get. And then I have a feeling that now it's going to work. But let me move the light out of the way. And I'm going to zoom you. I could be wrong, but I have a feeling. Because I know this was working much better than it is now at one point, and nothing blew up. I don't know what the heck I'm looking at there. Oh, let me zoom out. Oh my gosh. Gigantic bird meter. Okay. So, let's see. I'll key it on CW just so we can see that we're still, that's on CW. Yeah, let me key it just for a second. Yeah, we're getting 80 to 100 watts, which is about right. So now let me put on sideband and put my signal in. My signal's in. Key it. Nothing. Let me start turning up the modulation. Oh yeah. Oh yeah. Look, there's right there's not even 50%, and I'm getting 90. That's not even 50% of the volume, and it's still the 20 millivolts. And I'm going to check what the well, let me, while we're watching this on camera, I want to jiggle things over here and see if I can get to act up again. I'm going to turn it way down though. Turn it way down there. Let me just start jiggling these wires here. And I'm jiggling. Nothing. Wait. Nothing. So, I don't know. I'm just going to take the connector apart and recrimp the wires on the connector. But before I do that, I want to check and make sure that nothing changed at the collector, everything sounds alike. I'm going to make sure nothing changed at the collector up there, and if it didn't, we'll just crimp the wires and say that it's fixed for now. So let me zoom back to the scope for you, and we'll just take a look. Okay, back on the scope. Let me look at my 236 collector again here. We got 141.50 millivolts. Okay, so nothing's changed there, which still leaves that one question: is should I be seeing a half a volt there, like they're showing on the one block diagram of the transmitter? However, you saw that I was getting 100 watts with the 20 millivolts. So, like, I'm not even turn it off. We'll zoom it right back over to the watt meter again and see what we're seeing. So let's zoom in. Wrong, the other zoom. And I'll key it up. Yeah, I get full output at about half. When I have the mic control up to 5, I get full. Right now it's at, what, 4? What do I get? At 4 I'm getting 75, 70, 75. So I think that works the way it should work. Let me throw a microphone on it and try it. I mean, I always like being able to fix things without spending money. But if I didn't find the exact problem, I never quite know. So here's, the microphone's turned at 5. My face is about 8 inches from the microphone, and let's see. Hello. 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 Can you hear me? Well, that's not on peak. Let me turn the meter on peak. Hello. Hello. So I moved my face. I'm probably about 4 inches now from the mic, but again, the mic setting is at 5. I'll turn it up to 8 just to see. That's about 8 right there. Hello. So, all right. Well, looks like that issue's fixed. I guess it just wanted me to take the screws out of the thing and probe around, and then it would fix itself. So anyhow, like I said, I'll just take the connector back apart and just make sure that none of the pins, you know, I get a little straight pin in there, and make sure that all the terminals are bent nice, that they grab onto to the other end, and we'll put it back together. But you saw I was shaking it; nothing was changed, and I can even try a little bit of contact cleaner in it. So, well, fixed another one. Thanks for watching.